In this question, we need to find the domain of f. F is a function of x and y, so we need to find all the values of x and y where the function exists. This function is composed of ln and square root functions, so we need to consider those functions. If we look at ln looks like this, right? And the square root function looks like this. Right? So we kind of have to consider, okay, what are the possible values for the thing, the x under the square root or the x in the ln. So the possible values here, here we have x has to be greater than 0, right? Because we can't have ln of 0, that doesn't exist, right? And for here, x has to be greater than or equal to 0. So now what we have to do is apply these in the function that we have. And so this is just like an aside. Okay, so it's not part of the solution, but it's just aside. So now we have to apply this in the function. So in the function here, we know that ln, we have whatever inside the ln has to be greater than 0. So we have x squared minus y plus 1. This thing has to be greater than 0. And then we also have everything under the square root must be greater than or equal to 0. So we have 3 conditions that we must satisfy. X, y has to be greater than or equal to 0. And we have x has to be, and we have y has to be greater than or equal to 0. Okay, so we have 3 conditions that we have to satisfy. For each of them, we can kind of rearrange. Actually, for this one, it's easiest because we know y has to be greater than or equal to 0. For this one, we can rearrange, so we have it like y as a function of x, because we know how to draw those. We can isolate and solve for y. So we can move the y over to the other side. So now we have x squared plus 1 is greater than y. Okay, so we know how to draw this. X squared plus 1 is just a parabola, and it's shifted up by 1 unit, right? And we know that the y value has to be less than that, okay? So we can draw that easily. And then the other one is xy is greater than or equal to 0. For this one, think about when y, we know y has to be greater than or equal to 0, okay? So if y is equal to 0, then this whole thing equals to 0 because we have to multiply. But if y is non-zero and y is positive, what happens there? So this means that, okay, we can divide both sides by y. So we have x greater than or equal to 0. This is when y is greater than 0. Well, we know y is not 0, right? So y is not negative. So it has to be either greater than or equal to 0. So we're just looking at the case when y is 0. Okay, so I'm just going to actually write this in the blue color. We have x greater than or equal to 0. So that's what we have there. Okay, so now these are the 3 conditions that we have to satisfy, and let's just draw the xy plane. Okay, so here we have x, y, 0, and here let's say this is 1, okay, and we know, okay, the parabola x squared plus 1, it just looks like this. This is y equals to x squared plus 1, and y equals to 0. This is just this line right here. And x equals to 0 is that line right there. Okay, so we want to find out, okay, where is it greater than or equal to 0 when so here y is greater than or equal to 0, so it's above this line, anywhere above it, right? And then x is greater than or equal to 0 is anywhere above this line, right? And then we have y is less than x squared plus 1. So here's a parabola, and it has to be underneath that parabola. So maybe actually I'm going to just draw it 3 different colors. I'm going to draw in 3 different colors just so that we can see. Okay, so, and then I'll erase everything later. But anyway, so here this is y is greater than, or y is greater than or equal to 0. So it includes this line right here. And then the other one is x is greater than or equal to 0, and it includes this right here. And then the last one is, or the first one, I'm going backwards. The first one is x squared plus 1 is greater than y. So everything under that line. So here's this line, but we're not going to include that line because it's strictly greater than, right? Or y is less than x squared plus 1. So it's everything is under this. Okay? So if you can see, where do all these 3 shaded regions intersect? They intersect. I'm going to try to write it here. They intersect here, here, dot, 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 and here. So I'm going to just color this in. There. I'm going to get rid of all the other stuff so it doesn't look too messy. But pretty much that's what it looks like. And this is the domain of the function of, oops, domain of f of x